I'm Royce Davis, the Recycled Water Program Manager for the City of Boise, and excited to be recording this presentation about the Recycled Water Program and our groundwater recharge work. The agenda for today will be a quick update on the Recycled Water Program from September to January, some of the progress we've made, a groundwater recharge engagement introduction, and then what we call Groundwater Recharge 101. So we're excited to have the Public Works Commission dive deep into the details of our groundwater recharge program. The groundwater recharge work is important to us and important to the community, and we look forward to engaging the Commission over the next year. So just to review some of the overall Recycled Water Program outcomes, or our goal statement is: the Recycled Water Program will preserve local water by bolstering the local groundwater supply, protecting the Boise River, and creating resilience against the impacts of climate change. And just to review how we got here, it comes from the utility plan, so the 5-year planning effort that the City of Boise and Public Works Department worked on with the community and stakeholders. And really coming out of that utility plan was that all new capacity shifts to recycled water. So in addition to the Lander and West Boise, the river discharge, enhance the river efforts, and all the other work that we have, that all new capacity shifts to recycled water. And out of that came the beginning of the Recycled Water Program. So how will we use recycled water? Or what will the Recycled Water Program use the water for? We prioritize the end uses off of our highest and best use policy. And currently, we take industrial source water, which will flow to the recycled water facility. We'll purify the water. And then the two current prioritized end uses are groundwater recharge and industry reuse. There's also opportunities, could be in the future, for irrigation or other uses, but currently those are the two highest prioritized end uses that we are pursuing. So the progress report, we had our second National Water Research Institute panel of experts, where we brought in some water experts from all around the country. Most were in person and a few online, and we were able to present to the panel about the Recycled Water Program, all of the work that we have done, and the work that we're planning to do in the coming years, and be able to get feedback from the panel on topics like groundwater recharge, on topics like treatment technology, and different things. All different parts of the program. Again, that presentation is on YouTube or online if you wanted to watch and see how the panel went. And we're currently working on getting a report back from the panel, which will be publicized as a public document, where we answer questions from the panel. They answer our questions, and there's some public questions as well that we'll answer in the final report. So that should be April or May of this year. We should have the final report. What's coming up next in a few months? We have continued to conduct the site characterization and groundwater modeling. So we'll continue to collect water samples and geological and hydrogeological geochemical information. We'll start to design the future recycled water facility. So what treatment technology will we use, and size them, which kind, those types of things. And then we'll continue to run the pilot through the summer until the fall for community engagement, community tours, to be able to continue to work and inform the public on the Recycled Water Program. So those are some of the things that we'll continue to work on over the next few months and year. In 2024, it was planned, we'd have at least 3 public works commissions that we would be able to present. The first one didn't work out again in May, and I think in August, those two commissions will be able to present and work with you all on the recycled water program. So first, to talk about our groundwater system. If you look, this is a graphic that we had made. It is Boise pretty much. If you look, we have reservoirs and river that runs through town, and there's also rain. There's irrigation. You got irrigation laterals running through, irrigating crops. There's some ponds, different things. So it's similar to our groundwater system. So all of those things infiltrate into the ground and provide groundwater for the local area. So those are all different ways that we get water into the ground. And then manage groundwater recharge. So along with the river and infiltration that takes place in the valley, for groundwater recharge, there's really two methods. One is a recharge well, or also called injection, or the other one is an infiltration basin, where the infiltration, the water naturally percolates in through the soil and into the ground. And the recharge well or injection, you would basically put the water in a specific location. So again, on the right there, the picture in California of a groundwater injection well. So that's what it basically looks like, is pipes that go into the ground. There's really not a lot to them really, other than some piping and valves and flow meters and different things. And then on the left in Gilbert, Arizona, is an infiltration basin, which basically looks like a large pond where the water would naturally infiltrate into the ground. So those are the two options, two ways to do it, which we'll obviously have to make that decision in the future on how Boise or the recycled water program is going to put water in the ground. So a couple examples from around the country, in Potomac Aquifer in Virginia. There they do groundwater recharge for saltwater intrusion. And then also in Idaho, there's Eastern Snake River Plain Aquifer, which they've been taking, I think, water from the Snake River and infiltrating the water through the basalt to replenish some of the groundwater in the eastern side of the state. And then we also wanted to mention United States Bureau of Reclamation. We have a Water Smart grant that we received from them for $1 million for a planning grant. We mentioned that just because there is a lot of municipalities, states, and cities that are pursuing recycled water or water reuse. It's becoming very popular throughout the country, as not only Boise, but a lot of different cities plan to try and secure their water future. Two of our goals for the groundwater recharge piece of the program: one is to increase groundwater quantity, and the second piece is maintain or enhance groundwater quality. Groundwater recharge, how will it benefit the Boise community? The first one is by keeping water local, or resource recovery and reuse, by taking the purified water and injecting or infiltrating into the ground. We're able to keep the purified water in Boise, where now we treat the water at the water renewal facilities, and the water goes into the Boise River or downstream to other communities in different places. So the recycled water program and groundwater recharge allows us to keep the water local, as you can see from the graphic there that we developed. The second one is maximize the investments for the greatest community benefit. Some examples of this would be economic development. We create increased discharge capacity at Lander and West. So there's a lot of different pieces to that, but part of that is the recycled water program, as the community grows, it's a good way to plan for the future and future water use for Boise. Groundwater recharge, it produces a consistent year-round location for the purified water. So it's really, we create a new water supply for Boise. Looking ahead, we're going to do the groundwater recharge 101 today, where we introduce key terms and topics. And then May, we'll do groundwater recharge 201. We'll go over water quality considerations and recharge methods. And then August, we'll go over modeling and site method, review preliminary results. So, and that's all. That is the current plan, which will be edited based off of how fast and how much work we can get done prior to those sessions, but that is the current plan. Okay, groundwater recharge 101. So really some of the overview of the questions that we're hoping to answer today. What is the groundwater recharge regulatory environment? What work are we doing to build a program that is protective of our community and existing groundwater users? And we'll go over site characterization and groundwater modeling. So 3 of the decisions that we will need to make is 1, where will we recharge the groundwater? 2, what water quality will we achieve? And 3, how will we recharge the groundwater? So where, what, and how. So where, currently we're looking at 2 locations, which we've highlighted these in the past, which we call them Site A and Site B. Site A is where we have 2 wells, and then Site B we have 1 well. And we're doing the site characterization work on both of these sites. And to note, Site B is the location that we recently purchased for the recycled water facility. So whether we can do the groundwater recharge on the same site, or if we have to use Site A or both, I guess, are all the 3 options that we have. So geological testing, we really look the groundwater system analysis, hydrogeological testing, and geochemical testing and modeling. So when we look at these Site A and Site B, these are the 3 areas that we're gathering data and information to be able to make decisions in the future. So the site characterization and action. So I think there's the top right is Site A, and then Site B in the wintertime there. You can see the drill rigs. And then the left is the actual geological characteristics for the site. So every 5 feet, we'll take a sample and collect that so that we know every 5 feet what the geological characteristics are. So that's kind of what the geological piece is. We basically take samples that we can use for future testing. This graphic, this is one that I like. It's got a lot of detail into it, which is kind of hard to see and define the detail, but the key there basically outlines the different layers in the lithology for Site A. So it's not exact, but it's pretty close to what you would actually find in Site A. So with the topsoil, the basalt layer, at 800 feet, there's an ash layer, which I'll mention in a minute. You can see where the groundwater, the blue line, that's where the groundwater starts, which I think is about 300 feet. And then you have the 2 well depths, 1 well to 800 feet and 1 well to, I believe it's 500 or 600 feet. So that's representative Site A. If you look at the pictures there, on the right side, I like the picture like you're driving up from Lucky Peak. You go across the bridge there before you come up, and you look to your left or right, the black cliffs. You can see the basalt layer, and then underneath that basalt you have layers of sand and gravel, which is basically what you find on Site A and Site B as we've drilled through both sites. We've drilled through that basalt layer. And then the reddish picture is if you were to get a up close picture of the basalt, that's what it looks like. And then on the left is an ash layer, I think was from around 800 feet. And again, that's something that we actually sent that off to Boise State University, where they're going to take and do an isotope analysis to determine the age or the timing of that ash layer. So that's something we were able to coordinate with Boise State. Okay, what is a groundwater model? So again, we have the modeling work that's going on, and I'll just read these here that, it's basically a computer model that simulates groundwater conditions and interactions between groundwater and surface water. It illustrates predicted water levels and flow directions based on pressure and elevation, and it can describe groundwater, surface water, and chemical transport. And basically, it tells you, to me, it's where does the water go when you put it in the ground? Does it head south to the Snake River? Does it go north to the Boise River, east or west? How fast does it move? At what rate? And where does it go? So a lot of those things with that model, but it should be able to tell us all of those different things. The three pieces of the groundwater model are site characterization data, so the data from site A and site B, the model calibration. So the modelers will use the USGS model or GS model to, and then we'll use well information from area wells and different water quality information to calibrate the model. And then the third piece is that Treasure Valley groundwater flow model. So we take those three pieces, put them together, and we'll get our recycled water program groundwater model. Both Idaho Department of Environmental Quality and Idaho Department of Water Resources are basically joint regulators. There's a water reuse permit and a underground injection control permit that comes from Idaho Department of Water Resources. And really the regulations vary depending on the method, the source, and use. So it's almost on a case-by-case basis that you work with the regulators on your permits for the program. As a minimum, the requirement is included to maintain the groundwater quality. So as we start to get water samples back, and we can look to see what is in the groundwater on site A and site B, that gives us a good baseline to know that we need to at least meet those water quality requirements at a minimum. So water quality considerations. The quality of purified water the city recharges impacts the quality of the water already in the ground. So, we have the opportunity to, this is where one of our goals to enhance or improve the water quality. The recycled water program studies include considerations around how the purified water will interact with soils and minerals already in the ground. So that's the geochemical testing, which we'll talk about in future meetings, which is a lot there, and that's a very interesting topic, is how the recycled or the purified water interacts with the site A and site B geological characteristics and hydrogeological characteristics. And then the groundwater recharge program's purified water will be conditioned such that it maintains or potentially enhances the quality of the groundwater system. So three things to consider with water quality. We need to recognize the other well users in the area, or where the existing wells are, and where we are in location to those wells. Which goes to travel time, which really refers to the amount of time it takes for the recharged water to travel from point of recharge to another water user in the area. So if we inject the water on site B, how long does it take for that water to travel to the nearest well or user in the area, which is something that the model will be able to help us calculate. Either do travel time in years or in location. So a couple of different ways to do it. Just to highlight our goals is to increase groundwater quantity and maintain or enhance groundwater quality. So as you look through the materials of this recording and in future meetings, just to remind you that's our goal. So that's what we're trying to do with all of this work and all this effort, to be able to increase the quantity and maintain or enhance the quality. And we are really excited to work with the Public Works Commission on our recycled water program, and specifically the groundwater recharge work of the program. It's one of the, again, I think it's probably one of the more difficult pieces of the program that we have moving. It's one that's hard to understand, and it's very important that we do it right, and that's why we felt it's very valuable for us to work with the commission to get your ideas and your opinions on groundwater recharge moving forward. Thank you.